Okay, the theory for today is to look at tree diagrams. Tree diagrams are just another way to record the possible sample space for multi-step equations. They're the same as yesterday we looked at a array or a table. This time a tree diagram is similar, but it's I guess a bit easier to construct and it hasn't had as much writing involved. And the idea of a tree diagram is that we list our possibilities and then we just keep listing them as we go. So we can do them for 2-step or for more steps. In our example here, which I'll go through, there's actually 3 steps, but all the exercises we're looking at in this unit will be for 2-step. So what it said to us is, on the tree diagram, we can record the sample space for multi-stage experiments. Now what this one is, we are tossing a coin 3 times. Okay, so what we can do is we have a first toss. We can either get a head or a tail. So what I've done is I've just listed the sample space for the first toss. We can either have a head or a tail. Now if we get a head the first time, second time we can either get a head or a tail. So there are our possibilities. If we got a tail, had a tail the first time, after that we could get a head or a tail. So now what we can see is we can see our sample space. Our possibilities were head, head, or head, tail, tail, head, or tail, tail. Now in here it has got a third toss, so we'll have a look at a third toss. If we were to do a third toss, so that was our second. Our third, we'd be able to do the same sort of thing yet again. We'd be able to get either a head or a tail, a head or a tail, a head or a tail, a head or a tail. And then if we were listing our total sample space, our outcomes, all of the things that we could possibly get from our 3, we'd be putting those letters. So this first one was head, head, head. Next one was head, head, tail. We come down to the next one, head, tail, head, head, tail, tail. So you just follow the lines as you come down. Head, tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So that's how we list our sample space at the end. This is our sample space. We list it at the end after we have established what it is by listing our choices. So let's have a look at our chunk 1 example. Go back to a skinnier pen. It said the experiment involves tossing 2 coins, complete the T diagram. So that's just what we've just done. We've got a head and we've got a tail. We've got a first choice. So that was our first. We're able to throw either a head or a tail. And then our second one is just going to be, if we did a head the first time, we can then also dial a head the second time, or we can throw a tail. Tail the first time, we can have a head or tail the second one. And so my outcomes over here are just H, 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 T, T, H, and T, T. So there's the answer to A. Then B, it's asked me for the total number of outcomes. Total number of outcomes, I'm counting up my outcomes, is 4. Find the probability of tossing 2 tails. C. Well, my 2 tails is at TT. I've got a 1 in 4 chance. Probability of tossing 1 tail. So 1 tail, I've got 2. I've got 1 tail. I can either do my head tail or my tail head. 2 on 4 equals a half. And then my last one says what is my probability of tossing at least 1 head. So that gives me the possibility of one head or two heads because I've got at least. So there's three possibilities for that. I've got my previous two plus the two heads. 3 on 4. So that is all we need. That's our example for our chunk 1. If we come and have a look at our problems, what do you have to do? So for question 4, it's very, very similar. It's basically, well, it is exactly that example. Construct that table over here, work out your outcomes, and the questions are exactly the same almost. Complete the trigram. What's the total number of outcomes for B? C1, probability of obtaining 2 heads. Next one, probability of obtaining exactly 1 head. So in the third one, at least 1 head. So you can have 1 head or 2 head. And 4 was at least 1 tail. Then your next question is, now we've got a spinner with 1, 2, 3, and we're spinning it twice. So you're having a tree diagram. Remember, you're going to have 1, 2, 3. That's your first spin, and then you're going to do it 2 more times. No, you're only doing it twice. 2 second spin. Once you spun that with 1, you can get a 1, 2, or 3 in your next one, etc. So draw the tree diagram. Then once you've got the tree diagram drawn, list all your outcomes. That's what question 1 is. Now we want the probability of a 1 and then a 1. So it's going to be how many options you've got divided by the total number of outcomes. Then you're going to find the probability of a 1 and then a 2. So that's C. D. Find a 1, probability of having a 1 or 2 spun in either order. So you can have a 1, then a 2, or a 2, then a 1. E, find the probability that both show the same number. So 1, 1, 2, 2, or 3, 3. And the last one, find the probability that the numbers add up to 4. And I'm going to leave that to you. Look at the combinations, they need to add up to 4.